under their belt after today. And I want to get through at least 10.3 before we move on to law of sine and cosines. So today we're going to go over what we call the double angle identities. Okay, some people call them the double angle identities. Some people call them the, oh heck, I can't get things working right. Hold on a minute. There we go. And make this go down, and this go up. Double angle identities. Sometimes they're called double number identities, but most of the time they're called double angle. Okay, I'm going to put number under here because sometimes they're called double number identities. Okay, the double number identities are as follows, and these are plug and chugs. So these are not like you have to think a lot, you have to think a little bit and plug and chug. Cosine of 2a or 2 theta, whatever, is equal to cosine squared minus sine squared. And of course, you see that coming from the Pythagorean. Cosine of 2a, and you can use different, for cosine, there's 3 different ones. 2 cosine squared theta, alpha, whatever, minus 1. And then the cosine 2 equals 1 minus 2 sine squared alpha. And that's for cosine. For sine, sine of 2 alpha is equal to 2 sine cosine. And for tan, I believe it's 2 tan, 1 minus tan, I believe. 2 tan, 1 minus tan. 1 minus tan. So that should be your double angles. Now you can go to your handy dandy, and we're talking about these right there. And of course, you see they're written a little bit differently, but they're the same thing. All right, so let's talk about how to use them. Let's say I make up a given that the cosine of theta is equal to 3/5, and sine is negative, and the sine is negative. Find the sine of 2 theta. B, find the cosine of 2 theta. And C, find the tan of 2 theta. Now we know that the cosine is equal to 3/5. Now you can do this 2 or 3 different ways. All right. The first thing I'm going to do is I'm going to draw a triangle. And we know that cosine, Oscar had a hunk. So the adjacent is going to be here, and the hypotenuse is going to be here. So technically, you could figure what the leg is right here. That's going to be 20 square root of 25 minus what, 9? And square root of 16 is 4. So we know that that's 4. So if I know that the cosine is 3/5, now I know that the sine is what? Oscar had 4/5. Now it says right here that the sine is negative. All students take calculus. So you can mark out which quadrants. You can mark out that one, and you can mark out that one because the sign is positive in these two. And here it says the sign is negative. So chances are we're talking about the third and fourth quadrants. So we know it's negative, so we'll put a negative right here. And plug and chug. What is the sine of 2 theta? Sine of 2 theta, this is A. I'm going to go to the next page. I'm going to write everything down. We know that the cosine is equal to 3/5, and we know that the sine is equal to negative 4/5. And we want to find A, 2 sine of theta. I'm sorry, sine of 2 theta. Okay, so the sine of 2 theta is going to be equal to 2 cosine or sine of theta times cosine of theta. Now watch this. This is real simple. 2, what's the sine of theta? Negative 4/5. What's the cosine of theta? Now that's extremely difficult, isn't it? Y'all supposed to say, hey, that's easy. Okay, don't say anything. Just keep everything to yourself. Just keep everything to yourself. That's fine. I don't want anybody saying anything in my class. I want everybody to be quiet. Or is y'all concentrating? Is that what it is? Y'all concentrating?
Yes, sir.
Okay. Questions so far? So 2 times 4 is 8. 8 times 3 is 24 over 25, and you feel good about yourself. All right, now I'm going to let y'all find the cosine and the tan. Go ahead and find the cosine and the tan. Now, before you do the tan, you're not necessarily going to have to use the double angle identity for the tan. But you will use the cosine, the double angle identity for the cosine. And I'm going to use the one that looks like the Pythagorean identity, cosine squared minus sine squared. That's the one I'm going to use.
Would you mind going over how you got the negative 4/5 for sine again? I'm just a little confused.
Yeah, sure. Sure. I'll do a different page. Okay, they told us that the cosine, or they told us in the problem that I got, they said that given the cosine of theta is equal to 3/5, and the sine is negative. Sine is less than 0. Okay, and blah, 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 blah. Well, when you first start off, you've got to get the sign, because most of your double angle identities, if you hadn't noticed, is in terms of sine and cosine. So this is Oscar had a hunk. So this is a triangle, and the adjacent is equal to 3, and the hypotenuse is equal to 5. We've got to find the opposite. We don't know the opposite. We don't know it. So therefore, one leg of the triangle opposite is equal to the square root of c squared minus b squared. We'll call this A. Okay? And A is equal to 5 squared minus 3 squared. And A is equal to the square root of 25 minus 9. A is equal to 25 minus 9 is 16. A is equal to 4. So our opposite is equal to 4. And we know that the sign is negative. This right here means the sign is negative. So whatever I get the sign of, it's going to be a negative number. So the sign is equal to Oscar had. And that's going to be equal to 4 over 5. And I put a negative in front of it because the rule says the sign is going to be negative. Does that help?
Yes, sir. Thank you.
Okay, now let's get back to the cosine. The cosine of 2 theta. I told you I was going to use the one that looks like the Pythagorean. Cosine squared theta minus sine squared theta. What's the cosine? 3/5. What's the sine? And that's going to be 9 over 25.
Yeah.
Minus, and that's going to be 16 over 25. 9 minus 16 is what? 7? And that's it. Tangent of 2 theta. Well, always, when you're talking about the tangent, you always can make tangent equal to what? Sine over what? Sine over cosine. So that would be the sine of 2 theta over the cosine of 2 theta. And that's going to be, well, we said that the cosine of 2 theta is negative 25/24. So that's going to be negative 24 over 25. And we just got, I'm sorry, I just did backwards. Sorry. The sine of 2 theta is negative 24 over 25. And the cosine of 2 theta is negative 7 over 25. Multiply by the reciprocal. We get 24 over 7. Now that shouldn't be hard at all.
No, sir.
See, like I said, the first 3 or 4 identities is verifying. And then after that is plugging and chugging. Now this next one, it says verify the given equation is an identity. Verify the given equation is an identity. And that'll be cotan of x sine of 2x is equal to 1 plus cosine of 2x. So I'm going to start off with the left-hand side, and I'm going to rewrite the left-hand side in terms of sine and cosine. So I'm going to start with the left-hand side here. And I'm just going to draw a little squiggle line through there, because I'm going to work with this side. And we know that the cotan is cosine over sine. Times sine of 2x. Now I can rewrite the sine of 2x using the double angle identity and get 2 sine cosine. I'm going to rewrite this. Since we are doing double angles, I'm going to write a different color. That would be 2 sine cosine. And now I put all this together, and that's going to give me 2 times the sine of x times cosine squared of x over sine of x. And the sines cancel. And I'm left with 2 cosine squared of x. And that's going to give me, I hate to write it like this, but I'm going to go over here, 2 cosine squared of x. And you could rewrite 2 cosine, well, the cosine squared of x, you could write that as 2 times 1 minus sine squared. But I'm trying to get it to look like this. So we could make it, trying to think how to get there. Cosine squared of x. One plus cosine of 2x.
You have a work email.
I'm thinking. We know that in the identities, let me go back to the identities. We know that the cosine of 2 theta, is equal to 2 cosine squared of x, right? Minus 1. Now I can solve this, and 2 cosine squared of x, I can take that across the river, and that's going to be 1 plus cosine 2 theta. Well, we've got 2 cosine squared of x. So 2 cosine squared of x is equal to, by double angle identity, which is right here. Excuse me. That's 1 plus cosine of 2x. You could say that. That is equal to that. Now, this is an example of a verification with some of these that you can plug and chug. You can always do verifications with identities, always. Okay? It's just like the Rubik's Cube. When you pick up the Rubik's Cube, or you pick up those 2 horseshoes with the chain and the ring around the chain, you do not learn how to do it the first time. It takes practice and it takes exposure. And you have to learn how to do it. And the only thing that you're going to learn is do them over and over and over. All right, let's try another one. Let's see if I can find another one that I like. You can simplify with identities. Simplify cosine squared of 7x minus sine squared of 7x. Well, that looks just like cosine. That looks just like cosine of 2x. Look at your cosine of 2x. Your cosine of 2x says that you can rewrite cosine of 2x as cosine squared. So theta is equal to 7x. Theta is equal to 7x. Oops, sorry. So theta is equal to 7x because this is there and this is there. So basically you can rewrite that as 2 times 7x, cosine of 2 times 7x. Okay, remember, the cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. Okay, so we know that theta is right here. Well, we've got 7x, and this looks like that, and this looks like that. So I can rewrite the right side as the left side and say cosine of 2 times 7x, which is equal to the cosine of 14x. So this is where you have kind of a simplification / verification. You got a simplification because you're taking this and you're simplifying it into the left side, which is a verification. All right, now you try this one. Simplify sine of 15 degrees, cosine of 15 degrees. Same setup. Go ahead and take a minute and finish that one using the double angle identities. So the cosine of 2 theta is equal to the cosine squared theta plus or minus sine squared theta. So we know theta is equal to what? 15. No, we're going to use the sine on this one because that's squared. My bad. We're going to use the sine of 2 alpha. Sine of 2 theta, sorry, is equal to 2 sine theta cosine theta. Now, the only problem with this is that this is a 1 right here. And we've got a 2 right here. So we've got to get rid of that 2. And the way that we do that is we rewrite it with 1/2. And that 1/2 times that 2 will give us that 1. And we know that theta is equal to 15. So that's going to be 1/2 sine of 2 times 15. So that's going to be 1/2 the sine of 2 times 15, which is equal to 1/2 the sine of 30 degrees. And 1/2 times 1/2 is equal to 1/4. Now see, this one, we actually ended up solving it. Now, when you do one like this, you need to look at it. What you need to do is take it home and look at it and let it sink in, because remember the sine of 2 theta, that's right there. But you got the 1/2 out here because you had to make it a 1 right here, so this 1 would match up. So you ended up multiplying both sides times 1/2. And when you do that, you get 1/2 sine of 2 theta on this side, and that's 15 goes right there, and you get 30. And then, of course, the sine of 30 is 1/2. And 1/2 times 1/2 is 1/4. And when we go over some of these, Tuesday, because we're going to have some homework questions, I know we are. When you go over these homework questions Tuesday, it'll start sinking in, and then you'll get used to them. But right now, you're doing a lot of writing and a lot of what, huh? Well, let's give it till Tuesday, and when we go over some more homework problems, you'll know what's going on a little bit better. Okay, here's one. Find the values, find the 6 trig values if the cosine of 2 theta is equal to 4/5. And theta is between 90 and 180. And it's not equal to, it's greater than, less than. And we're going to start with the cosine of 2 theta is equal to 1 minus 2 sine squared theta. Give you a hint, we're going to start with that one. So of course, you know that you can go through and go ahead and find the sine I am. Well, we know that the cosine of 2 theta is equal to 4/5. So I'm going to go ahead and see what this looks like. We're talking about Oscar had a hunk. So 4 and 5, 25 minus 16 is 9. I'm just thinking out loud. 25 minus 16 is 9, so that would be a 3. I'm just thinking out loud right now. I'm not saying that's part of it. But the cosine of 2 theta is equal to 1 minus 2 sine squared theta. We know that the cosine of 2 theta is equal to 4/5. We're going to subtract 1. Subtract 1. And that's going to be negative 5/5 plus 4/5 is equal to negative 2 sine squared theta. And now I'm going to negative 5 plus 4/5 is negative 1/5. Divide by 2, divide by negative 2 over 1, divide by negative 2 over 1, which means you're going to multiply by negative 1 over 2. So sine squared theta is equal to, well, that's going to be a positive 1/10. And of course, excuse me, take the square root of both sides. Sine of theta is equal to 1 over the square root of 10, which is basically the square root of 10 over 10. Now that's the type of problem I would put on a test. Now, of course, once you find the 6 trigonometric, once you find the sine, then you can find the rest of it. Okay, so how do we find the rest of it? Well, you know that the sine is equal to Oscar had. Okay, so let's draw that out. But remember, most of trigonometry is find out where you are. And we know that it's positive. This is positive, so it either has to be in the first or second quadrant. And it says between 90 and 180, that's the third quadrant. This right here is the third quadrant. So you know that this triangle is going to fall in the third quadrant. I'm going to draw it. I'll draw it in a light blue. Okay. Oscar had. Then we know that Oscar is square root of 10. And 10 is right there. And I'm going to use my Pythagorean theorem. And that's going to be 10 squared minus square root of 10 squared. And take the square root of that. And that's going to equal, we call it A for adjacent. Well, 10 squared is 100 minus 10, and that's equal to 90. And let's see, I don't know, we could break 90 up into anything. 9 times 10. So 9 square root of 9 times square root of 10. 3 square root of 10 is equal to A. And 3 square root of 10 is going to be negative. So let's go back to our Oscar. I meant sine, cosine, tangent, cotangent, secant, cosecant. The sine we know is 4/5, or wait a minute, square root of 10 over 10. And the cosecant would be 10 over the square root of 10, which is 10 times square root of 10 over 10, which is square root of 10. It should be the square root of 10 for the cosecant. So square root of 10 is that. Now I want you to fill out the rest of them. Go ahead and fill out the rest of them.
Quick question. Would you mind explaining why it's negative 3 root 10 instead of just positive 3 root 10?
Because it's on this side.
Okay, thank you.
You see, that's negative x. That's why. I mean, I don't mean to sound simple, but that's it. If this triangle was down here, then the negative would be here and the negative would be on the square root of 10. See what I'm saying?
Yes,
if
sir.
It was down here. And remember, all students take calculus. So the sine and the cosine, the sine and the cosecant are both going to be what? Positive. The rest of them should be negative. Oscar had a hunk. A is here. So that's going to be negative 3 square root of 10 over 10. And the cosecant is going to be negative 10 over 3 square root of 10 multiplied by the square root of 10 over square root of 10, negative 10 square root of 10 over 30, and that's going to go out and you get negative square root of 10 over 3. And that would be the secant. Okay, now the tangent. Oscar had a hunk of square root of 10 over negative 3 square root of 10. Square root of 10 over negative 3 square root of 10. Square root of 10 over square root of 10. And that's going to be, that'll be 10, because square root of 10 times 10 is 100, which is square root of 100 is 10. And then negative 3 square root of 10, square root of 10 is 10. So that'd be negative 30. So it'd be negative 1/3. And that would be the tangent. And the reciprocal of negative 1/3 is negative 3. Now that's a good question. You might want to write that one down. I like that one. Find the 6 trigonometric values of the cosine of 2 theta is equal to 4/5. And make sure that you get it in the second quadrant. I don't know why I put third right beside it. That's the second quadrant. Second quadrant. All right, let's try another. I'm trying to go over the ones that I think, I'm looking through your homework and seeing the ones that I'm thinking I might use. How about write the sine in terms of the sine of x. So I want you to take a minute and think about, and you'll see this in Calc 2. Think about how you could rewrite the sine of 3x in terms of like addition of sines or addition of angles or something.
You could do sine 2x.
I'm sorry, what?
Or I'm sorry, you guys have to work on this by ourselves.
No, you said sine of 2x what?
Sine of 2x would be sine of 2x times sine x, or would it be plus?
Sine of 2x plus x, but you're on the right track. That's why when I heard you say 2x, I was like, okay, somebody's paying attention. All right, sine of 2x plus x. Now use this right side over here to see what you come up with on this.
We can use, we factor it out, and then we can use the identities, right?
What?
So we can factor it out and then use our x, correct?
Yeah, you're going to use sine of 2x and sine of x. Yes. Now remember your sum and difference identities that we went over in 10.2. And this is plus, and you're talking about the sign. So that's going to be sine, cosine, cosine, sine. And that's going to be sine of 2x cosine x, sine of 2x cosine x, cosine 2x x. And you can bring that 2 on the outside, or you could factor out I'm just thinking, you got sine of 2 theta. Sine of 2 theta, you can rewrite that as 2 sine cosine. So this can be rewritten as 2 sine cosine. 2 sine of x cosine. Yeah, 2 sine of x cosine. Using the double angle identity. Times cosine. You can rewrite this cosine 2x as I like to use that Pythagorean identity looking, cosine squared minus sine squared. Running out of room. Now I'm going to distribute this cosine and this sine, and I'm going to get 2 sine x cosine x
Wouldn't it be just 2x cosine squared x? Because that's all one value.
Yeah,
right?
2 sine x cosine squared x. Thank you. I was trying to add them. I'm sorry.
You're fine.
2 sine of x cosine of x, and then this is going to be, this one has a negative. That's what I was looking for, that negative right there.
Yeah.
Plus, this would be sine cosine squared x minus sine cubed x. Now, you can rewrite cosine squared of x as 1 minus sine squared of x. So that's going to be 2 sine of x, 1 minus sine squared of x. And I'm going to take my highlighter. And I'm going to highlight that cosine squared. I'm using my Pythagorean identities. And I'm going to do the same thing there. In fact, yeah, I'm going to color that yellow, and I'm going to move it to the front. Move it out to the front. So that's going to be 1 plus 1 minus sine squared x times sine of x minus sine cubed of x. So the reason I picked this problem is because it has, it has a little bit of everything. It has the Pythagorean identities, it has the double angle identities, and it has the sum and difference identities. So this is a good test question. What I mean by test question is, it might be on the test, but it's a good question to study to get ready for the test because you have everything in this one problem. And now we can combine like terms after we distribute this one. So we're going to distribute this one, and we're going to get like sine cubes and all this other stuff. So that's going to be 2 sine of x minus 2 sine cubed of x plus sine of x minus sine cubed of x minus sine cubed of x. Good gracious. I didn't expect all that. And I'm going to highlight the cubes. So this is 2 cubed of x minus sine. And I'm going to take my orange. Let me take blue. And I'm going to highlight these two. So the blue, what is 2 plus 1?
3.
3 sine of x minus what? 4 sine cubed of x?
Yes, sir.
Now, of course, like I said, I don't think I would put that on a test as far as, I might put it on a test, but it would only be like 1 because it takes time to do something like this. But you've got, first of all, you've got 1 writing 3x as the sum of x's. That's one thing. Then you've got sine of 2x, cosine of 2. You're using the sum and difference right here to go from here to here. And here you're using the double angle identities. So you're using 3 things, not to mention your algebra. Oh, and you're using your Pythagorean identities right here. Pythagorean. Oops, cosine squared, sorry. And cosine squared. So this one has everything in it. And I know some of y'all are about ready to head explode.
That knocked a lot of cobwebs loose.
What?
That helped. That knocked a lot of cobwebs loose.
Well, yeah, and some of y'all, like I said before, haven't seen trig identities before. So you're going to have to let it sink in a little bit. Okay? And it will work its way out. Think of, you ever have a silk shirt or a silk shirt or silk pants or whatever that you're going to iron? Oh my gosh, it's very difficult, and you got to start a little bit at a time, and then eventually you get all the wrinkles out of it. Okay, and that's what you're doing, especially with those people that haven't seen identities before. You're going to have to, you know, a lot of people say, well, I need an index card to put all these on. Well, get you an index card and blow that green sheet up. I got one right here. Take this green sheet and like blow this part up and put that on an index card. And then your double angle identities, blow that up and put that on an index card. And your Pythagorean, your tangent, reciprocal, I would put all three of these on one index card. These three right here are the ones that kind of, you know, verify. These are the verification ones right here. So you could take your handy dandy highlighter. You need to highlight these and put these on one index card, because those are kind of like the basics. Okay. And then these right here, do these in blue. Oh, I've got a surprise for y'all. Hadn't been confirmed yet, but I may be teaching a Sync 140 next semester. And this one, those two right there, and we're fixing to go over another section, but I'm going to start it today. Those two are the first two that we're actually plugging and chugging. And we're going to go over these next. This law of sines and law of cosines, that's the next test. I don't think I'm going to test you. I'm going to test you separately on these. And these aren't that big a deal, and these aren't that big a deal. We don't hardly ever use these. We're going to get to these eventually. And some of these others are not, we don't need to worry about these down here. These are the main two that we're going to go over next, and they're plug and chug. So don't let it overwhelm you. Just like when you pull a garment out of the dryer and it's got all these wrinkles in it. You just got to take a little bit at a time, a little bit at a time. And after a little bit of time, you can get all the wrinkles out of it. Some of y'all say, don't know what the heck I'm talking about, but some of y'all do. It's not going to hit you like a brick. You're not going to faint, and by osmosis, you're going to know how to do identities. If math was that way, everybody'd have an engineering degree, and it's not. Math is just like playing a musical instrument. How many of you play a musical instrument? Nobody in this class plays a musical instrument.
I played the trombone, but that was like in 6th grade. No, 5th grade.
Okay, well, let me ask you a question. Did you wake up one morning and were you able to play the Star Spangled Banner on the trombone just one morning?
No.
No. I tried to, Mr. Parrish. I took 2 years of piano. I wish I'd stuck with it. But you don't. It took me 2 years, and I still sucked at it. Why? Because you get out of it what you what?
Put in.
You get out what you put in. If you don't put in the time, you're going to suck at it. And contrary to popular belief, that's the way life is. And no matter how you sugarcoat it or how you try to take, we are a product of our own decisions, and what we put into that decision is what we get out of it. And there ain't no getting away from it. All right, here we go. Let's talk about sum to product. Product to sum. Right now, I'm going to talk product to sum. The cosine of A plus B is equal to cosine, cosine minus sine, sine. We already talked about that, okay? And the cosine, hold on. Okay, the product of sum identities, I showed you, they're right here. So I'm going to write them a little bit bigger for you. Cosine of A, cosine of B is equal to 1/2 brackets cosine of A plus B plus cosine of A minus B. Sine of AB is equal to 1/2 cosine of A minus B plus minus cosine of A plus B. It's kind of backwards. Sine of A cosine of B is equal to 1/2 sine of A plus B plus sine of A minus B. And cosine of A sine of B is equal to 1/2 sine A plus B minus the sine of A minus B. Now you could actually solve these for the sine plus the sine, and you could actually get the sum to product. But it's easier just to rewrite the sum to product. Here is an example. I'll write it down at the bottom and then I'll just start on another page. Rewrite cosine of 2 theta sine theta as either the sum or difference of 2 functions. Okay? So take a second and look at it. We know that it's cosine and sine. So cosine and sine, it looks like this one. All right, plug it in and see what you get. It's real simple. It'll only take you probably 30, 45 seconds. Okay, so here we go right here. 1/2 brackets sine of 2 theta plus theta minus sine of 2 theta minus theta. And that's going to be, I'm going to have to go to the next page. I'm going to fold this in half so you can keep it on the screen for you. You know, the things I do for y'all, y'all should be thankful. All right, so 1/2 sine of 3 theta minus sine of theta. 1/2 sine of 3 theta minus 1/2 sine of theta. That's it. So see, as you can see, half the battle is just matching up which one to use. That's half the battle. And I'm going to show you, and that's the summed product. After I sneeze. Corona.
Bless you.
All right. Thank you. Now, I want everybody to look. I'm not going to write these down, okay, because they're right here. Okay, let's see if I can I zoom in on that? Let's see. Can I zoom? Well, look at there. I tell you what, I'm amazed myself. Look at there. So I want you to write those down. If you haven't, everybody should have printed out this thing, but I guarantee you there's 1 or 2 of y'all out there that didn't print it out. But I'm not going to say anything because I don't want to embarrass you. So there it is right there. So copy those down right quick. And I'm going to go show you an example, and all you're going to do is plug and chug. I'll give you a couple more seconds, but I'm not going to leave it up there much longer. I've got like 6 minutes before y'all start to self-combust. Not all of us can sit in the basement and do nothing. Bad, Hubert. I shouldn't have said that. When things get tough in life, what do? You sit in the basement. Nobody's catching it. I figured somebody would have caught it. I guess not. And here is an example. Write or rewrite, however you want to say it. Write the sine. Oh gosh, this thing's zooming. I gotta. Zoom. There we go. Write the sine of 2t minus sine of 4t as a product of 2 functions. Notice this is different. So you're going sum to product. where before we were doing product to sum. Okay, this is sum to product. So we got to find sine minus sine. Sine minus sine is the second one right there. Plug and chug. 2 cosine, and I'm just following this little sheet right here. 2 cosine, and that's going to be alpha and bravo. So 2t plus 4t over 2 times times the sine, times the sine of 2t minus 4t over 2. And that's going to be 2 cosine of 6t over 2, sine of negative 2t over 2. And as Dr. Harden used to say, yeah, 2 be negative 2 cosine of 3t sine of t. And that negative basically is from here. That negative right there, I pulled it out front. It's right there. Now, I'm sorry, but that's not hard. Unless you want to make it hard. And yeah, granted, there are some of the homework problems that are a little bit tough. Okay? But it's not, it's not undoable. Now, the only other ones I want you to make a note of is the half angle or half number. I want you to make a note of those, and then here they are right here. I want you to make a note of those. So you're right now, you're responsible for 10.2 and 10.3. You're responsible for those. Okay, so that's what I'm going to test you on, those 1, 2, 3, 4, 5 sections. And you're not talking about a lot of questions on the test, probably 10 questions. It's not going to be a lot. And besides, if you have to use these in calculus, you're going to use a cheat sheet anyway. So it's not like, all you have to learn how to do is use them. Okay. Now, I did want to show you that. Let's see if I can pull up that calculus right quick. I wanted to show you that calculus. Now, it's not 100%, but I was asked the other day if I wanted to teach it. And I said, yeah, I want to teach it. And they said, well, I'll get back with you. And that's what my boss said. So I'll show it to you right quick, and we'll go from there. But just right now, I don't know. It's not 100%, but it looks pretty promising, I hope. Let me see if I can find it. Where did she send that? She asked me about the 140. I'm trying to find it. Hold on. Where is that? There it is. Yeah, there it is. Do you want the 140? Do you want the 140? I'll give you that 140 number. Give me a second to find it. All right, where is it? There it is. Y'all write that down if you know. Right now, there's a chance I may be teaching it.
Quick question about another class.
Huh?
Did you ever get that class for Math 120 on
Well, I'm glad you mentioned that because I may be teaching the 10 o'clock class. Because I can't teach. She wants me to teach this 140, I think. And that 120 is the 10 o'clock. It's right down here. Did everybody get that written down? 4:30:21. Y'all got that written down? Okay, they don't care. All right, the 120 that you're thinking about is right here. 120:10 at AC, right there. That's the one I may be teaching because I can't teach the 8 o'clock 120. So that's the one I may be teaching when she finishes up. But nothing's in concrete yet. I'll let y'all know. But there is a chance I may be teaching the 140. And I'm not saying I'm the best calculus teacher in the world, but I'm not the worst. I can tell you who the worst is. And I'll shut up. Okay, anybody got questions?